right, guys. Day 3, well, day 2 of algebraic vectors, but this is day 3 of vectors altogether. And we're going to look at one last way that we can talk about vectors and we can write them. And this is really going to lend itself to what are called algebraic vectors, and where we can add, subtract, we can multiply vectors algebraically. Okay. So first, I need to explain something. A unit vector, okay, unit means one, okay, a unit vector is a vector with a magnitude of 1, okay, so there's a vector right here, starts here, it goes to 1, so that's the point 1, 0 right there. So this vector is a horizontal unit vector, and we use the letter I to represent a horizontal unit vector. This is a unit vector. It's a vector that is 1 unit long, but only travels in the vertical direction. And we're going to call that vector J. So a horizontal unit vector, vector I, this is vector J. If we use these two letters, we could represent any vector in space as the sum of a bunch of these little unit vectors. So, for example, first off, this is what we did last lesson. This is a position vector. So vector AB, it's traveling A units in the X direction and B units in the Y direction. So that means this vector is traveling A, whatever that number is, of these little I vectors plus B of these little J vectors. So let me use some real numbers to make this kind of sink in. If I gave you position vector 3, 2, so this is the vector that goes 3 to the right and up 2. We could write it this way, 3i plus 2j. So it is a vector that goes 3 of these little I unit vectors. So 1, 2, 3. So that's 3 i's. And then we would add 2 j vectors, which are the vertical vectors. So I'd go up. Now you're not going to have to do this. This is just me trying to connect the geometric vectors to these algebraic vectors. So here's 2. Okay, so we've got I plus I plus I plus j, which remember when you add vectors, you start where you started, you end where you ended. So this would be vector 3i plus 2j. And that's another way you can describe a vector. So this is a position vector, and this is using unit vectors to describe the direction of the vector. You're using the same numbers, it's just a different way to write it. Okay? Now, where this is handy is when it comes to adding and subtracting vectors. Okay? So if I have two vectors, so if I have vector v, which is some number I plus some number j, and I have some other vector w, which is some number I plus some number j, so I'm writing these two as unit vectors, then the sum of those vectors would just be combining like terms. You would add the two numbers that are connected to the i's, you would add the two numbers that are connected to the j's, and then that's all you do. That's all you do. You just combine like terms, and that's the sum of v plus w. This is using unit vectors. This is using position vectors over here. Okay, so with position vectors, you do the same thing. You add the two x coordinates, you add the two y coordinates, and that would be your new vector. Okay, so don't look at this as one big thing. This is how you find the answer if you have unit vectors, and this is how you find the answer using position vectors. These are two separate ways of doing this. If you're going to subtract vectors, same way. The only thing you got to do is you've got to make sure you distribute your subtraction. Okay, that's always the thing that gets people in algebra, is they forget to subtract this one over here. They only subtract the first thing that they see. Okay, and then lastly, multiplying a scalar. So this was how we multiplied scalars geometrically. We took I, we took another I, we took another I, and we had 3 i's. Well, when you have a vector written using these unit vectors, all you do is you distribute. You take whatever the x value is, you take whatever the y value is, and you just make sure you multiply both of those by whatever that scalar is. So they're writing the scalar as some number alpha, and so they're distributing the alpha in here, they're distributing in there, and that's where you're going to get your answer. So this is an explanation. Let me show you some examples, and these are going to be real easy when you look at some examples. So here's what I've got. I've got vector v, which could be written as the unit vector 6i minus 2j. So this is a vector that's going 6 to the right and going down 2. Okay, that's how this vector is traveling. There's another vector, which is 2i plus 5j. So it goes over 2 and goes up 5. So it's going a little bit more to the north, if you want to think of direction. Okay, so, and then I'm going to give you all these little examples down here. So what would v plus w be? Well, we are simply going to combine like terms. We're going to take the 6i and the 2i, and we're going to get 8i. We're going to take the negative 2j and the positive 5j, and we're going to get plus 3j, and we're done. That's your answer. This is the vector you would get by taking this vector, drawing it out, adding this vector, drawing it out, and then connecting your initial and your ending. You would get a vector that travels 8 units in the x direction and goes up 3, because this one was going down 2, but then this one went up 5. So altogether, you're going to get a vector that goes up 3. That's it. That's the entire problem. For example, B, v minus w. So we're taking this vector, 6i minus 2j, and we are subtracting this vector, 2i plus 5j. So again, the trick is distributing. Taking 6i minus 2i and getting 4i. Taking negative 2j and subtracting 5j, which is going to be negative 7j, and that is our answer. That's the unit vector that you get by taking v minus w. Okay, what would 5 times v look like? Well, if this is v, 5 times that vector would simply be 30i minus 10j. That's it. That's the vector that is 5 times as long as vector v. Okay, look at example D. What is 2v minus 3w? Well, so I want 2v's, so I'm going to take vector v, and I'm going to distribute that 2 and double it. So that'll be 12i minus 4j. And then minus 3w. So what I'm going to do is I'm going to take this minus 3, and I'm going to multiply w by the minus 3, by that negative. And that'll distribute the negative for me so I don't forget to do it later. So minus 3 times 2, that's going to be minus 6i. Minus 3 times 5, that's going to be minus 15j. And now I can just combine like terms. 12i minus 6i is 6i. Minus 4j minus 15j would be minus 19j. And that's it. That's your answer. E, that's magnitude. Okay, we learned that last lesson. So what is the magnitude of v? Well, that's just going to be the square root of 6 squared plus negative 2 squared. Okay, don't ignore that minus sign. It's there, but it's going to get squared. Okay, put these parentheses. That's going to be, what, 36 plus 4. This is going to be a positive 4 now, so that's 40. Now, I'm not going to stop there. 40 is 4 times 10, and 4 is a perfect square. So I'm going to take the square root of that. I'm going to write it as 2 radical 10. That is the magnitude of vector v. Okay, now look at F. This is the one that confuses people. Look at what this says. It says, what is the magnitude of v plus w? So you've got to think of this like the order of operations. You can't find the magnitude of the vector until you know what the vector is. So the first thing we're going to do is we're going to add these two. We're going to take vector v, we're going to add vector w. So, well, we already did that over here. So let's use that answer. And that's what we want to find the magnitude of. So add those two together, 8i plus 3j. And this is the vector we're finding the magnitude of. So that's going to be the square root of 8 squared plus 3 squared, which will be 64 plus 9, so that's 73. And then that doesn't simplify, we're just done. That's your answer. Okay? All right, one last thing, and this we're kind of going to go backwards. Okay, what if I gave you the magnitude? So I didn't tell you the xy coordinate of the vector like I did up on these two. Instead, I'm going to tell you the magnitude of the vector, so how long is the vector, and I'm also going to tell you the direction that the vector is traveling. Okay, so I'm going to use an angle. I'm going to say it's going 30 degrees, or it's going 90 degrees, or 120, or whatever. So I'm going to give you the magnitude. I'm going to give you the direction. Well, the last way of writing a vector is what's called polar form. Okay, so vector v can be written in polar form as the magnitude of the vector times, and then in parentheses, you've got the cosine of its direction, I, because cosine is the x direction. So if you take the cosine of that angle, that's going to be your horizontal direction. So it's going to be that amount, I, plus the sine of that angle, j, and then you can just simplify it. So again, they're going to give you the magnitude, they're going to give you the angle, and we're going to plug it into that formula, and I'm going to show you what's going to happen. So the magnitude of a vector is 6. The angle that the vector is traveling is 60 degrees. So how would I write the vector as a unit vector? Well, I would put 6. I would put the cosine of 60, I, plus the sine of 60, j, and now I'm just going to simplify that. So you may need to go back to you may need to grab a chart, have a chart handy, so you can do this. But the cosine of 60, so cosine 60 is 1/2, so this will be 6. So this is 1/2 I plus, well, if the cosine of 60 is 1/2, the sine of 60 is going to be radical 3 over 2. So radical 3 over 2, j, that j is still there, and then we're just going to distribute the 6 in. 6 times 1/2 is 3. 6 times radical 3 over 2, well, we're just going to let the 6 and the 2 cancel each other and give us 3 radical 3 j, and that's it. This is our unit vector. It's a vector that goes 3 in the I direction, and then 3 radical 3, which would probably be about 5 point something, in the y direction, and that's the vector. That's all you do. So plug the numbers in and then simplify. This last example, okay, 3, and then it's the cosine of 225 I plus the sine of 225 j. That's what you would do. Now, there's a trick on this one, and that's why I gave it as an example. This angle, 225, think about where that's located. 225 is past 180, so that's in quadrant 3. So don't forget, when I do the cosine of 225 and I do the sine of 225, which that's like a 45-degree angle, right? It's 45 past 180. I'm going to make both of these negative, okay? So the first thing I'm going to do is take the cosine of 225, which is going to be negative radical 2 over 2i. I'm going to take the sine of 225, which is also negative radical 2 over 2j. And then I'm just going to distribute the 3 in. So that's going to be negative. So 3 times this fraction is just going to be 3 radical 2 over 2. There's no simplifying. The 3 and the 2 don't reduce or anything. So it's just 3 radical 2 over 2i. And then it's plus a negative, or you could just write minus. 3 times that is going to be 3 radical 2 over 2j, and that is your answer. That is the unit vector, or the vector written in unit vector form with that magnitude and that direction. And that's it.